Imagine a world where robots aren't just pre-programmed automatons, but intelligent assistants capable of understanding your instructions and adapting to the ever-changing chaos of the real world. Sounds like science fiction? Think again. Google DeepMind just unveiled Gemini Robotics and Gemini Robotics ER, two powerful AI models poised to revolutionize how we interact with robots and redefine the very meaning of automation. Are we on the verge of a new era where robots possess something akin to instinct? Let's dive in and explore this exciting new frontier. On March 12, 2025, Carolina Parada, a leading figure at Google DeepMind, announced the arrival of Gemini Robotics, an advanced vision language action VLA model. Built upon the already impressive foundation of Gemini 2.0, this new system takes AI capabilities to a whole new level. Now, you might be thinking, Gemini 2.0 was already pretty amazing. What's the big deal? And you'd be right. Gemini 2.0 was celebrated for its multimodal reasoning abilities, its talent for deciphering text, interpreting images, and even parsing audio and video. It was a master of the digital realm. But here's the crucial point. It was largely confined to the digital world. It didn't address the practical realities of how a robot might physically interact with its surroundings, how it could manipulate objects, or navigate a real-world environment. Think of it like this. You can read all the cookbooks you want, but that doesn't automatically make you a skilled chef. You need the practical experience of handling ingredients, using kitchen tools, and adapting to unexpected mishaps to truly master the culinary arts. Similarly, Gemini 2.0 had the theoretical knowledge, but it lacked the embodied intelligence to translate that knowledge into physical action. Enter Gemini Robotics. This new system bridges the gap between the digital and physical worlds. It's designed to directly control robots by generating physical actions. Not just text or code, but concrete movements. It's like giving a robot a nervous system and a set of muscles, allowing it to respond to its environment in a meaningful way. But the innovation doesn't stop there. Google DeepMind also introduced Gemini Robotics ER, where ER stands for embodied reasoning. This sister model brings advanced spatial understanding to the table, giving robots the ability to comprehend how objects exist in physical space, how they might move, how they can be grasped, and how to plan a path for a robotic arm to achieve a specific goal. Imagine you're trying to explain to someone how to stack boxes of different sizes in a storage room. You wouldn't just tell them the dimensions of each box, you'd also talk about weight distribution, stability, and how to maximize space utilization. Gemini Robotics ER provides that same level of spatial awareness to robots, allowing them to approach tasks with a level of understanding that was previously unattainable. It's akin to giving AI an extra layer of problem-solving superpowers specifically tailored to real-world tasks. Let's get into the specifics. Gemini Robotics is fundamentally a vision language action model. This means it processes visual information like a video feed from a camera, understands instructions given in natural language, meaning you can talk to it just as you would a person, and then generates an action plan to control a robot. Picture this. You want a robot to fold a piece of paper into a complex origami crane. Or maybe you need it to pack a lunchbox with a sandwich, an apple, and a juice box, all neatly arranged in a Ziploc bag. Gemini Robotics can tackle these tasks, even if it hasn't been specifically trained on that exact scenario. This is a monumental leap forward from traditional industrial robots. These older systems require meticulous, manual programming to perform even the simplest new task. Think of a car assembly line. Each robot is programmed to perform a specific weld or attach a specific part, and any deviation from the predefined routine requires a technician to reprogram the robot. Gemini Robotics, on the other hand, demonstrates a remarkable level of generalization. In tests designed to assess how well it handles tasks it wasn't explicitly taught, Gemini Robotics more than doubled the performance of previous state-of-the-art models. That's not just incremental improvement, it's a quantum leap in adaptability. Consider the implications. It's better at recognizing new objects, understanding novel instructions, and adapting to changes in the environment. Imagine a robot tasked with sorting packages in a warehouse. If a package is slightly different in size or shape than what it's been trained on, A traditional robot might get confused. But Gemini Robotics can analyze the package, adapt its grip, and successfully place it in the correct location. This ability to adapt to the dynamic real world is crucial because, as we all know, things rarely go according to plan. Another key area where Gemini Robotics excels is interactivity. Robots operating in chaotic environments need to adapt on the fly. If someone picks up an object the robot was about to interact with, or moves something out of place, the robot needs to be able to react. Gemini Robotics continuously monitors its surroundings and replans its actions in response to environmental changes. Think about a home robot helping with chores. If you suddenly decide to rearrange the living room while the robot is vacuuming, it needs to be able to adjust its path and continue cleaning without bumping into furniture or getting stuck in a corner. Gemini Robotics provides that level of real-time adaptability. And because it's built on top of Gemini 2.0, it possesses advanced language understanding capabilities. This means it can process casual commands in everyday language. You could say, "Could you move those boxes from the table to the shelf? And by the way, keep the red box on the floor." And the model can understand the nuances of your request. It can distinguish between the boxes that need to be moved and the one that should be left behind. This is a game changer for anyone who envisions having a robot assistant in their home or workplace. Instead of needing to learn a complex programming language, you can simply communicate with the robot using natural language, making it incredibly user-friendly. Now, let's talk about dexterity. Performing delicate tasks like folding origami, packing a tightly packed bag, or even turning a doorknob can be surprisingly challenging for a robot. These actions require fine motor skills and precise control, which have traditionally been difficult to replicate in machines. Gemini Robotics, however, has demonstrated the ability to handle incredibly fine motor tasks. Google DeepMind has even released short videos showing robotic manipulator arms folding paper and picking up fragile items without damaging them. This level of precision is a critical breakthrough, and it's a major reason why many are hailing this model as a game changer. Then there's Gemini Robotics ER. Think of Gemini Robotics as the direct agent that controls the robot's movements and executes tasks. Gemini Robotics ER, on the other hand, is the brains behind the operation, the system that provides advanced spatial reasoning. It analyzes objects, determines their location in 3D space, identifies the best way to grasp them, and plans a safe trajectory for the robot to follow. Imagine you want the robot to pick up a coffee mug by the handle, from the right angle, without spilling the contents. That's precisely the kind of nuanced scenario that Gemini Robotics ER can handle. The truly remarkable thing is that Gemini Robotics ER can perform all of these tasks: perception, state estimation, spatial understanding, planning, and even code generation, without needing a collection of separate modules. This is a big deal because it streamlines the development process for roboticists. Instead of having to integrate and calibrate multiple systems, they can rely on a single, integrated model. In end-to-end testing, where the model is responsible for everything from vision to motion planning, Gemini Robotics ER achieved a success rate 2 to 3 times higher than the baseline Gemini 2.0. This demonstrates the power of embodied reasoning and its ability to significantly improve robot performance. And yes, it can even generate robot configuration scripts using Gemini 2.0's coding abilities. This means that if a task is particularly challenging, you can show the model a few examples of how to do it, and it will learn from those demonstrations. It's like teaching a robot by showing it, rather than by writing complex code. So how is Google planning to bring these models to the real world? They've partnered with Apptronik, a company specializing in humanoid robots, particularly the Apollo robot platform. Google is not just collaborating with Apptronik, they're also an investor. Apptronik recently raised $350 million, with Google as a significant contributor. This is a strong indication that we may soon see humanoid robots powered by Gemini 2.0 in the near future. But Apptronik isn't the only company involved. Other major players in the robotics field, such as Agile Robots, Agility Robotics, Boston Dynamics, and Enchanted Tools, are also participating as trusted testers of Gemini Robotics ER. This widespread testing across multiple environments and robot types will help accelerate real-world adoption. Interestingly, Google is also introducing a new dataset called the Asimov Dataset to measure and improve semantic safety in embodied AI and robotics. The name is a clear reference to Isaac Asimov's famous 3 laws of robotics. Google has been experimenting with a robot constitution, a set of natural language rules that the model follows to avoid unsafe or unethical tasks. They've developed a framework to automatically generate these constitutions, allowing the robot to be given specific instructions that align with human values. The Asimov dataset will help researchers test how well these rules work in real-world scenarios and how the model responds to moral or safety-based decisions. This emphasis on safety and ethics is crucial. Giving robots the power to act on their own raises important questions, especially as these systems become more general purpose and are deployed in environments like homes and workplaces. Google also has an internal oversight mechanism in place. Their Responsibility and Safety Council reviews how AI is being developed, and they consult with external experts about the societal implications of advanced embodied AI. This multi-layered approach to safety is essential for responsible innovation in the field of robotics. From a user perspective, the ease of use is perhaps one of the most compelling aspects of Gemini Robotics. Imagine having Gemini Robotics running on a new robot. You could simply say, in everyday language, pick up that box and place it in the corner. You wouldn't need to know any special programming language. The robot can also handle exceptions in real time. If the box is heavier than expected, or if someone shifts it a few inches, disrupting the robot's initial plan, it can adapt and adjust its movements accordingly. This is a complete departure from the old days of meticulously coding movement patterns line by line. For roboticists who still want a high level of control, Gemini Robotics ER can generate Python code or other languages to configure the robot's low-level controllers. And if you show it examples of how you want something done, it can pick up that style of programming or approach to movement and replicate it in new contexts. This is where the model's in-context learning abilities truly shine. So what does all of this mean for the future? We're on the cusp of a new era where robots are not just tools, but intelligent partners. Gemini Robotics and Gemini Robotics ER are paving the way for robots that can understand our needs, adapt to our environments, and perform tasks with a level of dexterity and precision that was previously unimaginable. This technology has the potential to transform industries, revolutionize our homes, and improve our lives in countless ways. Imagine robots assisting surgeons in complex operations, helping firefighters navigate burning buildings, or providing companionship to the elderly and disabled. The possibilities are endless, but with great power comes great responsibility. It's crucial that we develop these technologies ethically and safely, ensuring that they align with human values and are used for the benefit of all. What are your thoughts? Do you envision a future where robots are seamlessly integrated into our lives? What ethical considerations do you think are most important as we develop these technologies? Share your thoughts in the comments below. As I've researched and written about Gemini Robotics, I've been struck by the incredible potential of AI to transform our world. But I've also been reminded of the importance of ethical considerations and responsible development. It's not enough to simply create powerful technologies. We must also ensure that they are used in a way that benefits humanity. Stay curious, stay informed, and be an active participant in the conversation about the future of AI. Your voice matters. And finally, I wish you all the best of health and happiness. Thank you for joining me on this exploration of the future of robotics. If you enjoyed this video, please like and subscribe for more insightful content. Until next time.